Hi everyone. Can you hear me okay? Thumbs
Yep.
up. Nice. And you can see my screen? Cool.
Yeah, you can see the screen.
Great. So I'm Ollie, Haydon-Mulligan, and I work at Cookpad. And you can find me on Twitter here at Ollie Doodle Day. That is, oh, hang on, Ollie Doodle Day for no particular reason. And you can mainly find me tweeting jokes such as this one, which is my current favourite. Where do you stand on styles? I'm on the fence. Laughter doesn't travel very well over Zoom, unfortunately. Thanks. But today I'm going to talk about this. Although this is a name I devised before I actually wrote this talk, so it may or may not be an accurate summary of what follows. But hopefully I'm going to give some helpful practical tips on dealing with things going wrong for a user.
Lovely.
And there'll be some sort of semi-philosophical questions about what errors are that I'm not going to answer. So this is really a talk to myself, and I hope that it resonates with other people. But in the past, I've gone to some arduous lengths to make sure that when an application is trying to do fails, I'm able to give as precise feedback to the user as possible about what went wrong. So here's an example from a project I did a couple of years ago where I was dabbling with Trailblazer, and every controller action, so it's a Rails project built on with Trailblazer as the kind of basis for handling most of the business logic. Every controller action looks pretty much the same. They all defer to an operation, in this case section index, which carries out some steps and reports back. It kind of abstracts away all the logic about how to carry out the steps, how to keep track of what each step's doing, and how to abort and handle failures. So that's what an operation looks like. That's what that particular operation looks like. There are some steps. And I added a macro which is what Trailblazer calls it, which kind of captured and reported back on exactly what step has gone wrong if a step goes wrong. That macro looked like that. It's kind of reporting which step failed with a failure object that gives some information that's useful for knowing what to do with the thing. Prior to that, I had tried to kind of make my own thing that was inspired a bit by Trailblazer called that orchestrated service, and it had this thing called steps, which was for carrying out a bunch of steps, which would be declared like that. So when something goes wrong, the idea is that when a step fails, in Trailblazer, the step returns something falsy. Here it returns a feedback object that reports success as false. And then in both sort of examples, we then report back information about the failure within a result object. This talk is not about these ways of doing things, but I'm not saying that these kinds of approaches are really bad in principle, and they can kind of give structure to deal with a lot of the uncertainty that there often is about how to work through the logic for any particular problem. But they come with a lot of complexity, by which I mean kind of three things. So to make sense of any of it, requires some extra knowledge. So this thing on the right, the actions teams update class, I mean, if you look at that, it doesn't mean anything unless you know what is going on with this orchestrated service thing. So there's a burden there. There's then the complexity in how that thing works. So how, I mean, most of the time if you're using Trailblazer, you only need to know how to use it. But then if something goes wrong, or it's not working as you expect, you then have to dig into some kind of gnarly stuff to work out what's going on sometimes. And then thirdly, there's the complexity. I mean, these sorts of things are okay if you're doing a personal project, but if you're working in a team with existing ways of working, you're not going to, shift the practices to a completely different kind of framework or approach. So there's a lot of complexity with this kind of approach, and what I've increasingly sort of come to think or see is that the good intentions behind those approaches can be met in simpler ways. So I'm going to run through an example application with a sort of realistic-ish bit of business logic and some ways to try and simplify, to execute that as simply as possible. If there's an underlying point to what I'll go through, it's that it is simpler to deal with things going wrong when we focus not on this question. So when something goes wrong, what was it and how did it and why did it happen? But this question, when something goes wrong, what does the user need to know? What is useful to tell the user? So when something goes wrong, we really want to help the user through it. That's the main thing. And that can lead to a kind of temptation to be overly explicit about what went wrong, in the belief that that is helpful. But it might only confuse the user and while complicating things for our code. So if we focus on what the user needs to know, that will help them. And our job can become more straightforward. So now I need to switch to this beautiful piece of work. So hang on, I just need to get my thing in order. Okay, so can you see my little website here?
Yep.
So this doesn't do a huge amount, but I did find a nice GIF of falling snow for the background, which I'm proud of. So the idea is we want to let our users send letters to Father Christmas, because it's that time of year. So let's have a look at what's going on. We've got some controller logic here that probably looks very familiar. We get a form submitted. We want to save the letter and deliver the letter. And if that delivery fails, we want the user to try again. So our delivery method here needs to save the letter, then carry out a bunch of steps. So let's look at what this deliver method is doing. So let's ignore what it's doing here and have a look at this first. So we've got a bunch of steps that need to be carried out. We need to save the letter, and we need to do some things like maybe we want to alert the elves that there's going to be a letter on the way. We need to get the address on the letter, apply a stamp, sprinkle some magic to make sure it can get to Father Christmas, and then ultimately we want to post it. And another requirement is that we don't want undelivered letters left hanging around. That means if something goes wrong here, we don't want to have a letter saved. undelivered letters are going to cause confusion, and they add another state that we would need to account for. So we'd have unsaved, saved and delivered, and saved and undelivered, which would inevitably complicate handling things going wrong. And we're trying to keep things simple. So unless absolutely necessary, we're going to start out with the assumption that if a letter can't be delivered, we don't want to save it. So these are the steps we want to carry out. What can we do to ensure that if one of these steps fails, we return false or something falsy here, i.e. we don't get to the success path. So what that really means is if one of these steps fails, we don't want to carry out the remaining ones. Otherwise, we'd have to sort of store the failure and hold on to that and then return it at the end. So what can we do to terminate our steps if any of them fail? So we could do this, which would be pretty horrible. So nested ifs, gross. We could do like a series of guard clauses. Again, pretty gross. I mean, we could make it as sort of convoluted and gross as possible with something like that. And this is kind of getting into the realm of the a way to orchestrate a series of steps and carry them out and skip or terminate if something fails and report back. We're getting into the realms of the kind of complexity that we're trying to avoid. So what another option is we just carry out the steps and rely on them raising an error if something goes wrong. So just like that. What would that mean in practice? So things like we wouldn't go out of our way to rescue errors if any of these steps raise an error. So if a step calls an external API that might be down, then let's just accept that that's an error and not try and rescue it. If a step involves making other database changes, let's use a bang method so we don't get so we don't swallow the failure. If we need to find a record as part of one of these steps, let's use find, not find by. So essentially, we're saying that if these steps succeed, there won't be an error, and if any of them fails, there will be. So this assumes, obviously, that the steps shouldn't really fail. So if something goes wrong, something unlikely and unexpected has happened. And in general, if a particular step failing is a normal occurrence that we're expecting, that probably means the failure is linked to what the user has submitted. If they input X and we won't be able to deliver it because they've input X, and they might input X, then we probably should be handling that with a validation error in a way that lets the user rectify that that invalid submission. So that's kind of a different kind of failure from what we're talking about in these steps. In other words, if we're happy that the letter is valid, we should in general be able to deliver it. And the delivery is kind of a formality. So if any step fails, we'll regard it as an exception. And if the steps run without errors, they run fine. Okay, so then the next question is what do we do if the save fails? So we could raise an error again, like that. and abort the whole thing because an invalid letter will raise a validation error. But here's the question: what is it useful for the user to know? How can they fix the problem? If they're submitting an invalid letter, we want to let them know what is invalid about it, and and let them fix those problems. So we don't want an error on this line to block us from rendering the form with validation errors. So an error here is actually going to hinder the user experience. So instead of that, we are going to go with an if save. And what this means is we're kind of separating out the things that can go wrong that the user can fix if they submit by submitting a valid letter, from the things that could go wrong but shouldn't go wrong because the letter was valid and it should be a formality to actually deliver it. And the other thing is this transaction here. The other benefit of raising an error if any of these steps goes wrong is that we're then going to roll back the save because we're wrapping the whole all of this in a single database transaction. So let's have a look at. So this is what I've settled on here. And we can just have a quick look at what actually happens. If I submit with no body or sender, it's an invalid letter. So we don't get past if save, and we report back. We get to this branch and we report back the errors, and the user can fix the problems and can decide to fix their letter. And whoops, I didn't save that. Oh, that's good. Let's try again. Oh no. Ah, that was a preview. Whoops.
I think you got one other block that you haven't commented out again.
Oh crap.
Whoops.
Sorry. Thanks, Adam. So there's my lovely, smoothly saved letter. So I get my validation errors, and we've kind of had a preview of what's coming, which is when something does go wrong in these steps, what are we going to tell the user? We need to feed something back. So we could use the else branch here and re-render the form if a step goes wrong and raises an error. So that would kind of end up looking something like something like that. We'd be trying to maybe leverage validations on the model to report back within the form that some error has happened. And obviously that is starting to look a bit convoluted again. And we can come back to the question of what is it useful for the user to know? So do we need to be like this explicit about what has gone wrong if alerting the elves raised a, there was an API was down? Or can we just tell the user that something's gone wrong and ask them to try again? So let's go with just letting the error be free and letting the error be raised without rescuing it. So what's that actually going to mean for the user? So let's let me just so I need to get rid of this for a moment. And let's force an error to happen, like I did accidentally. So we're going to raise an error when we actually try to post the letter. And we need to restart because I've changed. So we're going to send a valid letter, but an error is going to be raised as part of one of the steps, and we're not rescuing that error. So we're not going to end up here. The application is just going to raise an error. Well, that's pretty horrible. And that isn't really what I mean. So instead of that, we can leverage this thing. So the exceptions app is used. So this setting, config exceptions app, is used in some Rails middleware called show exceptions. And the job of that is to rescue all exceptions, then convert them into a status code based on mappings that you can customize. And then if you set the exceptions app to be routes, what it will do is send on the request that had raised an error to the route that matches the error code. So for example, if there's a record not found error, Rails turns that into a 404 status code and routes to 404. So we can use that to render a much more friendly error page, which can be dynamic like any other controller. It can access our database. So if we have exceptions app is routes, and then if we look at our routes, we've got a route to match all of these status codes, and it's going to go to an errors controller. And our errors controller is going to set an error message, and it's going to render an errors show page, which looks like this at the moment. So let's try and see what that looks like. So we don't want it to be Ajax. I'm just setting that so that we're doing just a normal form submission. We want to raise an error. And we want a valid letter. Oh, that's what we didn't want to see.
You might need to restart the server.
Oh, yeah. Dum. Okay. So now we're rendering a nicer error page, and we've got an error message, and I'm using the translations here. But this still isn't ideal. The user then has to go back and then try again. So we can make it a bit smoother. So if we make this an AJAX request again, when we do an AJAX submission, the response from the errors controller becomes the response received by the browser. So the rescue within the middleware, the routes call, and the rendering of the response all happens before the browser gets that response. And then the browser can handle that as we wish. So instead of returning a full page of HTML and navigating to it, we can return a message and just show it as an alert without interrupting the flow of the user. So if it's an AJAX request, we're going to render a different message with a status code. And let's see what happens. So now we're just getting a less sort of intrusive alert. You can imagine this sort of sliding down and being nicer. But essentially, the user could, if this is like an actual, freakish API error, and the user just needs to try again, they could just try again like that. So this is kind of a much smoother experience. And I'll just show how this alert is hooked up to work with this response. So in the form, we have a stimulus, sorry, not in the form, in the layout. We have a stimulus action listening for the AJAX error event, which gets emitted by Rails UJS whenever there's a non-200 status code back from an AJAX response. And that's going to trigger the stimulus controller, the errors controller, to show the error. And we're setting the inner text of our alert target to be the message from the response that came from the errors controller. And we're showing the alert. So that's a smoother experience. Now there is a bit of a caveat here in that now that we've got an AJAX form, things when the letter is invalid become a little bit different. So in order to get this response with the validation errors, giving the nice useful feedback so the user knows how to fix the problem, that wouldn't actually work out of the box with Rails UJS. If we go to our letters controller, so by rendering new here with a Rails UJS AJAX request, the browser is going to receive like the HTML and it's not going to do anything with it. So there are a few options. So we could do the thing of rendering a JS partial that swaps the form on the page. We could, if the request is an AJAX request, we could return JSON and then handle that in the client side to swap in the form and maybe swap in other bits on the page. But that kind of, or we could return a response with a status code that isn't 200, and we could handle it within our errors controller. So if it's an invalid response, like a 422, we could find the form that's in the response and replace it. Or we could just show an alert that says there are validation errors and list them here. But what I have done is I've just added this thing that receives the page of HTML and swaps it in. So the advantage, I think, is the controller action stays exactly the same. So whether it's an AJAX request or not, we render the page again, and in the form in the client, we are going to receive that, and instead of just ignoring it, we're going to actually replace the page, the current page, with the page from the event, and that's how this is working. So with the AJAX request, we are simply subbing in everything that is in this div and replacing it with what was in the response from the controller. So I just got one more thing to say, and then I'll wrap up, is that so far I've kind of distinguished errors a user can fix, which broadly speaking can be managed with validation errors, and errors where something's gone wrong that they can't do anything about. And at the moment, we're just telling them to try again. But there are some errors that don't really fit in kind of either of those categories, like a feature isn't supported in a region and somehow the user's making a request from that region, or even authentication errors or authorization, or something about their request is like fundamentally broken. So those errors like could be handled in the same way. We could, within here, we could be raising like feature unavailable. If it turns out the feature is unavailable, we could go through we could then map that feature unavailable error to a status code like this. So forbidden would be 403. That would arrive at our errors controller. We'd render a message, and we'd then show an alert with that message, like, sorry, you can't access that feature. Describing it there, it sounds pretty convoluted, and the reality is that things like authentication, authorization, feature not being available, those can be checked before we carry out any of this, and that's why in general, I guess we kind of reach for before actions to deal with that sort of thing, and from there you can directly render an error message and a status code, or redirect. So the idea of hooking up the and kind of leveraging the exceptions app isn't really to replace more convenient alternatives, but hopefully it's a tool that can make users' experience when something goes wrong like relatively smooth, without making our code a lot more complicated, because this is all we need in order to let the user see errors that they can fix, to tell them that something's gone wrong and that they need to try again if something unexpected happens. And my final wrap up is 3 points. So the general point is thinking about what the user really needs to know can help simplify what you do when things go wrong. Do they need to know what actually went wrong when we tried to deliver their letter? Or is it enough just to tell them that something went wrong and that they need to try again? Slightly less generic point, errors can be a helpful tool when something goes wrong, and we should be open to them simplifying things when they are, when we're dealing with things going unexpectedly, abnormally wrong. And the practical point, the exceptions app middleware that Rails provides gives us a handy tool for handling errors for us, so we can keep our hands a little less dirty in our own application code. And that's it.